Welcome to today's Whiteboard Explainer. All right, apprentices, we are jumping straight into the high-stakes world of precision engine rebuilding. This is a place where respecting your tools is literally the only thing standing between a perfectly smooth build and a total catastrophic failure. Today, we're focusing on mastering the gripping and holding tools that are specifically tailored for the engine room, because treating your tools right, that's the foundational step to becoming a master technician. So let's just jump right in. Here's a quick look at our whiteboard syllabus for today. We'll start with a welcome to the shop and the golden rule, then meet our specialized tools, walk step by step through a piston ring install, and finish up with some professional tool maintenance. All right, section 1, welcome to the shop and the golden rule. So let's kick things off by establishing exactly why specialized tools even matter in a high-stakes shop. Think about this for a second. What actually happens if you use the wrong tool on a delicate engine part? I really want you to consider the physical contrast we're dealing with here. We're constantly working with these relatively soft, finely finished aluminum engine parts, but our tools are forged from hardened steel. If you apply a hardened steel jaw to a soft aluminum fitting the wrong way, you don't just scratch it, you gouge it, you warp it, and you completely ruin it. In this game, precision is absolutely everything. And honestly, that brings us right to the golden rule of the shop. Never use pliers on nuts or bolts. Guys, this is the ultimate rookie mistake, the kind that will instantly get you banned from the engine room. Pliers have these hardened cross teeth that are designed strictly for holding, not for turning. If you try to use pliers like they're a wrench, those teeth are going to bite straight into the metal, round off the corners, and totally destroy the fastener. It is a guaranteed one-way ticket to the Hall of Shame. Always use a wrench for your fasteners. Moving right along to section 2, meet the specialized tools. You simply cannot use general purpose tools for high precision assembly. It just doesn't work. Check out our primary engine tools here side by side. On the left, we've got the piston ring expander, and on the right, the piston ring compressor. Notice how their functions are exact opposites. We've got one tool specifically engineered to stretch and another one perfectly engineered to squeeze. Let's break down exactly how and why they do this. First up, the piston ring expander. This is designed exclusively to remove and reinstall piston rings. Now, you might be wondering, why can't we just pull them apart with our hands? Well, because piston rings are made of incredibly brittle metal. If you try to spread them using your bare fingers, you're going to apply uneven pressure and they will snap. And trust me, that terrifying little ping sound of a snapping ring, the one that instantly costs you $100 and delays your entire build, yeah, that is not a sound you want to hear. The expander grips the ends of the ring and spreads them perfectly evenly, so you can safely slip them right over the piston head. So the catch here is that once those rings are successfully placed on the piston, they naturally stick out. They're actually wider than the cylinder bore they need to drop into. And that is exactly where our second tool, the piston ring compressor, comes into play. This is a special type of gripping tool that wraps a dark metallic band super tightly around the piston. You use it to squeeze those expanded rings completely flush. That allows the whole piston assembly to smoothly glide into the engine cylinder block without catching a lip or, again, breaking a ring. Okay, section 3, piston ring installation steps. Who's ready to head into the engine lab? This is where the theory actually meets the metal. Here is your step-by-step workflow for a precision assembly. Step 1, use the expander to safely place the rings onto the piston. Step 2, apply the compressor right over the rings to squeeze them completely flush. And step 3, gently guide the piston down into the cylinder bore. The ultimate test of this process is that your piston has to move freely within the bore with absolutely zero ring damage. Let's zoom in on the mechanics of these steps a little bit more. Check out the precise hand action required here in step 1. As the jaws of the expander engage the very tips of the ring, you squeeze the handles and the jaws pull apart. It perfectly and evenly stretches that super brittle metal just enough to clear the diameter of the piston head. There's no twisting, no raw pulling, just a really smooth mechanical expansion. And now taking a look at the compressor we use for steps 2 and 3, I really want to draw your attention to the mechanism on the side of the sleeve. You see that Allen key lying right next to it? That's how we apply the tension. You wrap the dark band around the piston, insert the Allen key, or sometimes a ratchet, and you just tighten it down. This mechanism holds all that massive outward tension of the piston rings safely in check. It essentially acts as this incredibly strong, perfectly round extra hand, letting you cleanly tap the piston right into the block. All right, moving to section 4, professional tool maintenance. Listen, you just cannot do this level of precision engine work with neglected tools. A master technician is literally defined by how they treat their equipment. So think about this scenario. How often should we be oiling our tools in a humid shop environment? I want you thinking actively about the physical condition of your gear every single day, because when tools just sit in a toolbox, the moisture in the air is constantly looking for exposed metal to oxidize. The answer to preserving your gear is consistent lubrication. Specifically, you have got to lubricate the swivel point, the pivot joint of your pliers and your expanders, with a light oil. A dry tool is a stiff tool, and a stiff tool is going to ruin your precision and totally tire out your hands. Just a single drop of light oil on that pivot point keeps the mechanical movement buttery smooth and creates a barrier to stop rust from building up. Plus, cleanliness equals professionalism. When you're doing an engine rebuild, yeah, things get messy, but you must never leave grease on the handles of your gripping tools. Why? Because grease on a handle is a massive safety hazard. These tools rely on normal hand pressure. If your handle is slick with oil, your hand is going to slip right under pressure, and you're going to end up smashing your knuckles against a sharp, unforgiving engine component. Wipe them clean with a rag, store them neatly so they aren't banging together and damaging each other's finish. And finally, Section 5, Wrap Up and the Gripping Checklist. Let's lock in the core axioms you're going to need out there on the shop floor today. Here's your daily gripping checklist. Number 1, always select the right tool for the job. Please don't use an expander when you clearly need a compressor. Number 2, keep your tools clean and lightly oil those swivel points. Number 3, these hand tools are engineered to take normal hand pressure only, no excessive force, and definitely don't be using a pipe to extend a handle for more leverage. And number 4, our golden rule. No fasteners with pliers ever. And that brings us to the end of today's explainer. Take one last look at that checklist and ask yourself which of those rules is the most critical to your own personal safety today. Keep that in your head, because it is time to put the whiteboard markers down and go pick the steel up. But before you head out to the bays, ask yourself this. If a simple pair of pliers applied wrong can completely destroy a hardened steel bolt, what other hidden dangers are lurking in your toolbox right now? Have a great day in the shop, everyone.